In this example, let's differentiate the function x to the 8x. Remember, this case requires logarithmic differentiation because you need to learn how to distinguish cases of polynomial function. In this case, we use power rule, so x to the n gives you n, x to the n minus 1. Exponential function, which is, for example, a to the x prime. The derivative of this function will be a to the x, copy, times natural log of the base. So e to the x gives you e to the x, remember? But in this case, we have x to the 8x. Thus, this is the case where I like to call it input raised to the input function, or unknown raised to the unknown. While in the polynomial we have unknown raised to a number, exponential number to the unknown, and finally the third case is a mix of both or neither. So you cannot use power rule or exponential function rule. To fix the situation, you use logarithms. Logarithms are amazing and they help us a lot in different cases. So let's work through this problem. F of x equals x to the 8x. I'll call it y to be faster. X to the 8x. Step 1, I'll show you steps. I like teaching using steps. Apply natural log to both sides, ln of the left and the ln of the right. You will have natural log of y equals natural log of x to the 8x. Now you need to use properties of logs. Properties of logs say that if you have a natural log or log of any base, x raised to any power, say a, like so, where input, not the whole function, is raised to power. This power can go down, and by going down, I mean it can be multiplied by the whole function ln x, and it also can go back if needed. So we are going to use this property of log. It's called loss of logs, logarithm functions. Thus, this 8x is going to be now multiplied by the natural log. We will have so step 1, apply log to both sides. Step 2, use laws of logs. Use laws of logs. So we are going to have natural log of y equals 8x multiplied by natural log of x. And now we have a product of two functions instead of the case of function raised to the function. We start differentiation. Step 3 involves differentiation. And this case requires implicit differentiation. Implicit differentiation, because the function y is not given explicitly. Well, differentiating left-hand side gives me 1 over y, because log of y gives you 1 over y. But don't forget to use chain rule, times derivative of y with respect to x equals 2. And now we need to use product rule. Product rule says u times v prime is u prime v plus u v prime, like so. We have two functions, 8x and natural log of x. Derivative of 8x is 8. Copy ln x plus copy 8x. Differentiate ln x. Derivative of logarithm of x is 1 over x. Implicit differentiation. We're almost done. Step 4. Multiply by y to isolate the derivative. So I want to have y prime equals, in this case, dy dx equals. So it's going to be 8 ln x plus 8x times 1 over x, which we're going to simplify, why not, multiplied by y. So we multiplied by y both sides, left-hand side and right-hand side, to get rid of this fraction on the left. This could be an answer. However, and let me put it in black. However, not only we want to simplify x and 1 over x, but we also know what y is, if you go to the very beginning, you see that y is given. Well, f of x. I just named it y for convenience. It's x raised to the 8x. X raised to the 8x. So the last step, we did not have it before in implicit differentiation because y was not given explicitly, but in this case it is. Use the given y from the beginning. So the answer will be dy over dx equals 8 ln x plus 8, and I simplified x times 1 over x, multiplied by x raised to the 8 over to the x. 8 times x. This is the answer for part A when they just asked me to find a derivative before plugging everything in. I have two notes to make. Note 1, why did we cancel out x and 1 over x? You cannot divide by 0. What if x is 0? Well, we assume that x is not 0 because we will have 0 raised to the 0 case, and because we're also using logarithm functions. The moment we have anything to do with log, we have to put restriction on x is not 0, and in fact is positive. So because of that, you can actually divide by x. The second note is it makes sense that at the end we have this function. It is not exponential function, but we can see the logic that it did copy itself after all. At the very end, we could use the original function there. So we answered part 1. The second part says, let's plug 1 inside of this answer. Then f prime of 1 will be, parentheses, 8 ln of 1 plus 8, 1 raised to the 8 times 1, which gives me, what is logarithm of 1? ln of 1 is 0. Thus, I only have left 8 times 1, 8 multiplied times 1 raised to the 8. And that is 8. And that is the final answer. Hopefully using my steps helps you to see the logic. You don't have to remember all of these steps. If you understand the big picture, that's fine too. We're differentiating the function, applying log to both sides, using implicit differentiation. At some point we need to get rid of the 1 over y case, multiplied by y, isolate dy over dx, which is a derivative, get the answer by substituting the original function in wherever we have y. Thank you for watching and keep practicing.